Hello everyone, welcome back to Calculus BC. We're in lesson number 32 where we're continually talking about work. In the previous videos, we've talked about our tank being a right circular cone. We've also talked about it where it's just simply a rectangular prism. Or another shape that you may see is a spherical tank. Now, I'm going to tell you guys, just like before, that when I'm doing a right circular cone, I always make the corner or the base of our cone actually at the origin, because it's really easy to find the equation of our line in that manner. So if it's a spherical tank, my strategy for all of you is actually to make the origin the center of the tank. So I'm going to draw a spherical circle with my radius is 8. So I'm 8 up here, I'm 8 here, I'm 8 here, and I'm 8 here. All right, so that's the idea of what I want to do. And so you will, hopefully it'll make sense to you guys why I did that here a little bit of time. So I go ahead, and like I said, for all spherical tanks, I always make it the centers at the origin. It says that the radius is 8 feet. So again, we know that this distance here is 8. We know that this is also 8. We know that this is going to be -8, and we know that this is going to be -8 as well. All right. It says that we have it half filled. So we know that it's only to here. And so I'm going to go ahead, based on your knowledge, and you guys have seen other videos, I'm going to go ahead and start talking about work. And so the work that's going to be involved in this, I know that based on this picture, that it's going to be, well, where is the water? The water is going to be, or so in this case, oil. So it's going to be from -8 to 0. All right, so -8 to 0, because the base, the distance of y, these are always your y values, from -8 to 0. If this had been a full tank, then it'd be -8 to +8. So this is a half tank here. So that's the first thing I want to do. So this is an example where the bottom is not 0. I'm going to tell you guys in a second, if you did draw the circle, if you did draw the sphere where the base was at the origin, then something else would have to change. But like right now, just hear me out with this right here. And so we're going to go ahead and say, well, the weight is going to be 50 pounds per cubic feet. So our force, again, is going to be our weight of our liquid, in this case our oil, times the volume of our cross-section. So just like in the cone question, if I were to slice this guy, I'm going to have another cylinder. So I need to find the volume of the cylinder. Well, I'm going to go ahead and write down what the weight is. Well, the weight's going to simply be 50. So I'm going to go ahead and put the weight down first. So cylinder is going to be pi r squared h. Now our height, as we said in the many other examples that we've done here, the height is going to be our delta y. So that's going to be what height is. So we got to find our radius. And so why I chose to do the problem like this, ladies and gentlemen, is that I got to find this curve minus this curve, because the radius is going to be right here, right? The distance is going to be this r. This is the radius of our circle, in this case our sphere. So I want this curve minus this curve. I know that this equation of this circle is going to be x squared plus y squared is equal to 64, right? Because that's the equation of a circle with a radius of 8 at center of the origin. If I had moved the circle, up to here, the radius would still be 8, but our distance, our center, would be at 0, 8. So we would have to have the equation x squared plus y minus 8 squared is equal to 64. And remember, we want to solve for x. We need to solve for x. So this is a lot more complicated, but you can absolutely do it this way. And if you use this equation, then you would go from the integration from 0 to 8, right? Because it'd be half full, so it'd be 0 to 8. So if you chose to do this equation, you'd be integrating from 0 to 8. But I'm not going to do that because I think this is more complicated. Look how easy this problem is. Because remember, ultimately, we're trying to solve for x. And so I can use this equation right here to easily solve for x, because that's going to give me my right function. So x squared is going to be equal to 64 minus y squared. X is going to be equal to, and I'm on the right-hand side, so I'm going to use the positive root for this. So it's going to be the square root of 64 minus y squared. So this is going to be the r. That's our r. So I can go ahead and say, in this case, pi, and then I'm going to go square root of 64 minus y squared, all squared. So it's our radius squared. And then our height, again, is going to be our dy. And then the last thing I have to worry about is displacement. And I want to go above the tank. I want to go above the tank here. So I want to go and make everything, all the water to go above the tank with this, what you see right here. So again, this is y. This is my d, which is right here. So the answer is going to be 8 minus y. And again, ladies and gentlemen, what I like about this is that if we're at the center, right, we're midway through the tank, which is 0, we plug in 0, this water, or this oil, I keep saying this oil has to move up only 8 feet. If I'm at -8, if I plug -8 in here for y, I get y8 minus a -8, which is 16, which means that 16, this oil has to go 16 feet. So again, you know that you've got this right based on this right here. Now, I clearly am reading the question one more time, and it says find the work required to pump the oil 5 feet. 5 feet above the tank. So this that I've written so far is if it was just to the top of the tank. So I clearly didn't read the last little part right here. So the only thing that we need to modify in this problem is that instead of it being at 8 feet, we're going to go 5 feet above, which is going to be at 13. So we're going to rewrite this, and we're going to modify this by making this 13. So just like before, we want to go 5 feet above. So if we're halfway at the tank, we're at 0. We want to go 13 feet. So we plug in 0 here, we get 13. If we're at -8, we have to go a -8 or a +8, another 8, and another 5, right? And if you plug in -8, you're going to get that. You're going to get 8. You're going to get 13 minus -8, which is going to give you 21, which is 16 plus 5. So this is our actual solution to our problem. And so I'm going to leave it there for this video. I think this should be a short and sweet, simple one, and I will see you guys in the next video.